to our grade 11 video, and so we will be talking about trigonometry. So this is the first part, and trigonometry, we want to first obviously revise what we know from grade 10. So trigonometry is a branch of mathematics that deals with the relationships between the side lengths and the angles of triangles. So we're looking at the side lengths and the angles of triangles. So the first thing you need to know are the trigonometric ratios, and there are three of them. There's the sine, there's a cosine, and the tangent. So when we talk about the sine function, it's defined as a ratio of the side opposite the angle to the hypotenuse. And we know what the hypotenuse is. So if I draw a small little right angle triangle here, the hypotenuse is the one that is opposite to the 90 degrees, which is also known as the longest side. Hypotenuse, and there's the opposite side, and there's the adjacent side. So there's the angle over there. So basically what they are saying to us is that the opposite side divided by the hypotenuse is the sine function, and the sine function is the opposite side over the hypotenuse. And then we also have the cosine function, and they say it's defined as the ratio of the adjacent leg, or the side joining the angle on the right angle, to the hypotenuse. So the adjacent is basically A here, and it is the one adjacent to the angle, and there's the hypotenuse. So the adjacent side divided by the hypotenuse gives us our cosine function, and that is the cosine function. And then we have the last one, which is the tangent function. So the tangent function is the opposite side with the adjacent side. So it's the opposite side divided by the adjacent side, and that gives us tan A. Now there's something that they've also added here, that tan A can also be written as sine A divided by cos A. Now this particular thing is an identity, and it's called the quotient identity that we will be dealing with later on in this video. So the first thing that we're going to look at now is that the trigonometric ratios are also written in a different way when we look at the Cartesian plane, right? So here's our Cartesian plane. If we draw Cartesian plane quickly, small mistake. So if you draw our Cartesian plane over here, and you can see that in the Cartesian plane we have our x's and we obviously have our y's, but if we have a straight line going upwards like that, you can create a 90 degrees a 90 degree line to the y-axis, and a parallel line to the y-axis, and you'll have an angle there. And what you'd notice is that the y and the x, and then there will be r for the radius. And so what will happen is that the y would be our vertical height, and the x will be our horizontal height, our horizontal distance, and the vertical distance. And so if we talk about the sine of alpha, so this will be alpha, the sine of alpha, then we are talking about y divided by r. And cos alpha, we will be talking about x divided by r. And tan alpha, we will be talking about y divided by x, right? So it's y divided by x. So it still follows the general, or the basic definitions, that it's being the opposite side of the adjacent over hypotenuse, and the opposite side over the hypotenuse. And you'll also see that now, since we are working with the Cartesian plane, remember on this side of the Cartesian plane the x's are negative, and because they are negative, if you had to have a straight line that will fall onto the second quadrant, for instance, you would see that our x is negative x, but our y is still positive. But when we still do our calculation, it will differ. So now sine beta, which is measured anti-clockwise from the x-axis, positive x-axis, you would see that this would be positive. Y over r is still positive, because y is still positive on the second quadrant and r is still positive. But when we look at cos beta, where we have to take the adjacent side, which the adjacent side here is actually x, so it's negative x divided by r, which is positive, and therefore the cos function becomes a negative x over r. And also you'd see the same thing happening to the tan beta, where it will be minus y over r. Okay, and now this basically signifies something quite important that we need to take into note, and that is the fact that when we measure an angle on the Cartesian plane, you need to take into account which quadrant it is. So we know that this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, how are these quadrants divided? They are divided in this way. We first have in the positive x-axis 0 to 90 degrees when we are measuring anti-clockwise, right? So 0 to 90 degrees, that is the first quadrant, and then 90 degrees to 180 degrees is the second quadrant, and then 180 degrees to 270 degrees is our third quadrant, and then 270 degrees to 360 is our fourth quadrant. But now there's something interesting that we already seen at the first one, where we looked at the second quadrant. And basically in the second quadrant, you notice that only sine was positive, but the other two were negative. So here, it's a summary again. You can see that sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. But in the first quadrant, all of them are positive. But you can check this by just applying your definitions of what these trigonometric functions are, and placing that line in that quadrant and seeing how it would get affected by the coordinates being negative or being positive. So you can see that tan here is positive, cos is positive here, and in the first quadrant all of them are positive. Okay, so basically this is telling us all trigonometric functions where the angle here is acute, right? When it's acute, where it's between 90 and 180 degrees, it will be positive. It will always give us a positive answer. But if it is more than 90 degrees, it depends on which quadrant it falls into. Therefore, you will know when you use a certain trigonometric function, then it will be negative. So for instance, if we had cos 181 degrees, that will give us a negative answer, because we know it's in the third quadrant, it is negative, and the only thing that is positive is tan. So let's introduce what we call spatial angles, or what we also know as the spatial triangles. We only have two of them, and the first one is that we have one where it has 30 and 60 degrees, and this is 2 square root 3 and 1, and then we also have the 45-degree spatial triangle, and this will give you a square root 2 as the hypotenuse and equal sides of 1 and 1, right? And then these are just a small summary of those values that you find when you plug them into your calculator. Okay, so now we move on to what we call the trigonometric identities. Now there's going to be two identities that we're going to look at, and as I had said, with tan we want to also look at what the quotient identity is. So here we have the quotient identity, and we say, given that tan theta is equals to y over x from the graph below, and as you can see on the graph below, this y over x is actually the opposite side divided by the adjacent side. So tan theta can be defined as y over x in the Cartesian plane. But another thing that we need to note is that this r is equals to the square root of x squared plus y squared. Why? Remember now, this is a right angle triangle, and a right angle triangle is associated with what? What theorem does it mostly associate? It associates with the Theorem of Pythagoras. And the Theorem of Pythagoras is quite interesting. So the Theorem of Pythagoras would say that r squared is equals to x squared plus y squared. And we can use the theorem of Pythagoras because this figure here is a right angled triangle, right? So r is actually just the square root of x squared plus y squared. Now, notice that the trigonometric ratios are, from this particular diagram, for sine theta it's y over r, and cos theta is x over r. And knowing that, let's take tan theta is equals to y over r and multiply it by 1. Remember, when I say r over r, it's actually 1. So we're actually just multiplying it by 1, therefore it's not really changing the equation, but it's giving it some sort of different form in which we can look at it. So when we multiply r over r, we can say y over r times r over x, right? We just shifted the values so that it can suit the way that we want it to look. So once that is done, remember that in fractions, when we use fractions, when we actually divide fractions, we don't actually divide fractions. We can't actually divide a fraction. But what we do is that we convert that one of the fractions that is dividing the other, and we change the denominator into the numerator and the numerator into the denominator. And as you can see here, that is exactly what we did. Here we had x as the denominator, but here we have x as the numerator. And we had r as the numerator, and now we have it as the denominator. But notice something. Y over r and x over r are what we have taken into account, what we have seen, that sine theta is actually y over r and cos theta is x over r. So because of that, y divided by r is sine theta, and x over r is cos theta. And then that is our quotient identity. So that is our quotient identity, basically saying that when we have any tan function, it is actually equals to the sine function divided by the cos function. And then we have the most important of these identities, where you need to know from this point onwards, because you're going to be exposed to this identity many times. Okay, so recall that sine theta is equals to y over r and cos theta is equals to x over r, right? And what happens when sine to the power 2 theta plus cos to the power 2 theta? So what happens when we have squared sine theta and we add it with cos theta, squared theta, and what happens basically? So let's see what happens. So what we know is that y over r is equals to sine theta and cos theta is equals to x over r. And then when we substitute that in, we find that it is y squared over r squared plus x squared all over r squared. And since the denominators, remember your fractions rules, your fractions, and since the denominator is the same, that means we just add the numerators. So once we add the numerators, we actually have y squared plus x squared. But remember what I said about the theorem of Pythagoras, that r squared is equals to x squared plus y squared. Therefore, we can substitute y squared plus x squared by r squared, and so we'll have r squared divided by r squared, which is just 1. So this basically means that we have an identity that says sine to the power 2 plus cos to the power 2 is equals to 1, irrespective of the angles. But the angles have to be the same. Remember, the angles have to be the same on the sine and the cos. And that is our square identity. And then the final thing is just this quick example that I will not explain, but I'll scroll down. So I thank you and I wish you the very best. Good luck.
Coming to my face.